I will describe about this graphical representation of counterfactuals. Now we can use these two graphs for description. Here we have seen that counterfactual can be represented with structural equations, but with graphical models we can also describe it more properly. Now y of x equals to y outcome in the modified model mx. This is the real graph and this is the modified model. Now in this graph y outcome will be the our in our interest our interested that the result will be the result y of x that we are interested in. Now the surrogate gates of y are the nodes associated with y. We can describe surrogate as the variables that are substitute of y. For example, sometimes we cannot access variable y, then we can use this surrogate or substitute variables and work with those things. Now the surrogates of variable y will be the variables that transmit some variations to y. For example, here the variables that transmit variations to y are its parents, like here z3 w2 and the exogenous variable that is uy that is not shown here, and the variables then the parent variables of the path nodes that lies in the path of between x and y. So here that node will be, for example, u3, that is the exogenous parent of w3. These variables will have transfer variations to y variable. Now okay, now the backdoor criterion for is a variable set z will satisfy the backdoor criterion when this variable set will block all the paths between x and y uh, that have an edge towards x. For example, here this path, the in the set, so the set that satisfies the backdoor criterion will hold such variables that will block these all paths, and any descendant of x will not be in that variable set. We can then call that this variable set has satisfied the backdoor criterion. Why do we need that? We can say that if after conditioning, if this condition set satisfy the backdoor criterion, and then we can say that x and y of x becomes independent. That means x variable and y of x variable and y of x, that is y value of y had x equals to small x, will be independent. Okay, let's see in depth. Okay, so first, for calculating the p of y equals to x, y of y equals to y had x equals to small x. For the calculated probability, we come from some equations, like this is a multiplication rule, that is the total probability of a variable a. Okay, let's go slow. The total probability of a variable a will be equals to the conditional probability and probability of that variable, and sum of this conditional probabilities, and p of and a is dependent on these variables. So we can write this. So we can, this is a transformation of this, like for p of y equals to y given do of x equals to x, we can sum over all the z's. For example, here we have sum over all the b variables. A is dependent on those variables, so here y is dependent on those z variables. We will sum over those variables according to this formula. So it will be p of y, probability of y equals to y given x equals to x given and z equals to z into p of z equals to z. This is the adjustment formula. We can use it. So for this graph will be like here the variables z3 w2, and if you consider u3, so we have to consider for each of these variables in this adjustment formula. So, and another then comes this counterfactual interpretation vector. So if x and y can be independent by this z variable sets and that satisfy backdoor criterion, then we can say that p of y x counterfactual y in the given x x and z is equal to will be p of yx given z. That means that y of x, counterfactual y will be independent of p of x, y of x. Now another thing we have to keep in mind, that is when x equals to x, counterfactual y x will be equals to y. While these rules are needed for this derivation, like p of yx equals to y, using these first two equations, we can say that we will sum over z, and p of yx equals to y given z equals to z into p of z. This equation can be think of for those graph that I have shown a little ago. Now from this graph we can go to the second line with this counterfactual independent backdoor, that is if x is independent of y given this adjustment set, backdoor criterion satisfies set, then we can see right here x equals to x, since x and y does not depend, like it is just in reverse order here. And from here we can say that if since x equals to x, so p of yx equals to y will be equal to p of y equals to y. This can be from this equation 4.6. So we can say that p of yx equals to y is equals to sum over z, p of y equals to y given z equals to z, and x equals into p of z. So and we can also say p of y of x is another way of writing p of y equals to do of x, and this adjustment, this formula can be said as conditional ignorability. Now an interesting question is, we know that in this graph expected value of y given x and z is equal to expected value of z, since x and z is independent, becomes independent when we condition on z. Now we have, if we ask questions, if counterfactual y given x and z is really independent of y of x given z too. Now the answer is yes. X and y of x are diseparable. If they are divisible by this vector satisfy z, then they are independent, otherwise not. I have discussed it in the previous slides. Now we have to show if this for this graph. Now in this graph we have seen that we are checking that counterfactual, we are checking that p of these two are equal. That, like, this means what? This means what is if for skill z equals to 1 or conditioning on z, the salary would be increased if I had college education. Okay, in this counterfactual world. Now for this result, we can consider these graphs. Like it is not explained properly in this causal primer book, but it is this twin network is explained, and this explained in this causality Pearl 2000 book. Now here you can see that z is collider for x and u2 here and here also. This is just same graph with, this is the real world graph, and this is the counterfactual variable world graph of this same graph. So here z is the collider. So if we conditioning on z for like here we are conditioning on skill set to see counterfactual y. So when we conditioning z, this creates a path, so x and uz will be dependent, and this effect, causal effect of x, will be flow through this along this path, and it will affect this u of x or counterfactual y value. We can see that if we and if we condition on y variable also it will also flow the effect of x towards this y. That means counterfactual y. What does this mean? This means that if we are considering this counterfactual salary, this is the real world salary, this is the real world skill, this is the education level. So if we are conditioning the skill level, this education and the counterfactual salary are becoming dependent. That means that we have calculated in the with the linear equations that counterfactual salary depends on college education, and with this graph we can see that counterfactual salary depends on this college education. Why? Because conditioning on z skill level, we are creating this path, and x has effect on this counterfactual y. But if we do not condition on any of these variable, not z, not y, nothing, then x, college education, and salary will be counterfactual salary will be independent. So we can say that no, y of x given z is not equals to y of x yx given z. That means that this college education is has the effect on this counterfactual salary. For this reason, counterfactual salary is dependent on education level. And another important thing is that we have assumed that it will be linear Gaussian model for calculating this decision, that is I have inferred here to calculate this decision, and we have assumed that it will be linear Gaussian model. But with this graphical model, we can decide that there will be effect of education level to counterfactual salary without any kind of model assumptions. So this is our decision. And I have also studied counterfactual in experience setting. This is not so large topic. I will show it from the textbook. Here, that is, they gathered 10 individuals, each are differentiated with their 3 exogenous or characteristic variables. Then these are also gathered from the our structure or graphical model. But this y0 y1 it will not be found for each xy. These are observable, these are not observable, so we will not be able to find each of these variables. So it will be like this graph. For example, here that this is a true graph, but this will be the main experiment data, that for some variables, some participants, we have gathered this is the control group, and this is the treatment group. So here we have some participants, we have kept them in the control group. These dot are they are not observable, and the rest of the participants are kept in this control group, and we have calculated y value for this. Now they are saying that since we are randomizing this participant in these two control and treatment groups, the average mean of this group and this y group and this group's population will be this average of this group will be converged to the population mean. That means that difference between these two group truly with ground truth will is 0.90, and if we increase the sample set, then the difference then the population mean difference between the population this sample mean will be converged to 0.90. Yes, this is the till now is explained here. I have studied. I will study more from this counterfactual linear model. Thank you.